Well, hello, pre-calculus students and general seekers of truth. We are going to finish off our last example here from the last video. So we talked about finding the domain and range and asymptotes, and we've done a lot of that already. We found our domain, which is all real numbers except -3 and +4. We've found our asymptotes along with a hole, so we know that there is a vertical asymptote here at x equals -3. The hole is significant for reasons we'll see in a minute, and we know that the horizontal asymptote is going to occur at y equals 1/2. And the last part here, we're going to try to figure out what exactly is the range. So what I've done here is I've graphed this actually in some ways more accurately than Desmos here. So this tool, the computerized tool, shows me this graph, but it's actually inaccurate because we know that f of 4 it doesn't exist. There's a blank spot here. So my picture does show that there's a hole right here. Actually, and let me give you my scale because my scale is a little bit different on the x as it is on the y. So I'm going by ones in this way every 2 grids and by every 1 grid on the horizontal axis. So at x equals 4, there's a hole right here. And I'm going to draw a circle here just to indicate that there's nothing there. Okay, but let's be a little bit more specific. When x is equal to 4, we know the coordinates of the x coordinate of this is going to be 4, right? When we did this up here before. Now, to figure out the y value of this, coordinate, let's take a simplified version of this function. So what we have here is x plus 5 times x minus 4 over 2 times x plus 3 times x minus 4. We could simplify this a little by saying that this is really x plus 5 over 2 times x plus 3. So we can say that when x is equal to 4, right? In other words, if I were to substitute in f of 4, we should get f of 4 should be equal to. And I use the word should be because it's actually not, right? If it wasn't for the stuff that we just crossed off, it would be equal to this. So f of 4 should be equal to, let's see, 4 plus 5 on the top is 9. 4 plus 3 is 7 times 2 is 14. It should be equal to 9 over 14. Okay? So this point right here occurs at x equals 4 and y equals 9 over 14. So that's where our hole occurs. Now, why does this matter? Right? Well, I mean, the problem here doesn't ask for the hole, but actually the hole is important because that helps us to answer the last question here, which is perhaps the most difficult, which is the range. Well, from the graph, we can see that the range includes every number between -infinity, and the range is the y values, from -infinity up to 1/2. It doesn't actually touch 1/2. So the range is going to be -infinity to 1/2 in union with from 1/2 up to 9/14. And then from 9/14 up to +infinity. So this is a very tricky function for us to find the range. And hopefully you can see here, and that I've alluded to this many times, that the range is pretty complicated to find. There's actually more to finding the range than just this, but at this point, this is a good way to stop. And the level of complexity that you're going to have when you're dealing with the range is you want to look at the graph. You have some algebraic methods that we talked about in the previous videos, and then you also need to pay attention to the horizontal asymptotes, and you also need to pay attention to the hole, the y values of the holes as well. So let's kind of recap, in particular, the range here. And so the range, again, I want to clarify this, that finding a range right now, we don't know all the methods yet, but we do know enough to apply some of the methods. So first thing is that, I'm going to put a big star here, always start with a graph. Always start with a graph. And then some other things that you could do is you could use your knowledge of how the graph has been shifted or transformed. Okay, so you want to consider shifts, that's moving the graph back and forth. This is particularly useful when we talk about when we deal with the square root function. Then some other things that you could do is you could consider, you would check for horizontal asymptotes. So check for all of the horizontal asymptotes, and then also check for any holes, because the holes actually contribute quite a bit to the final solution in finding the range. Now again, there's more information to finding range than just this, but what we have so far, these tools, these methods that we have, is an excellent start, and you can deal with some fairly complex functions with just the methods that we have here. As always, always be